I will try to get through this as quickly as I can. I think today, I feel a lot of responsibility for your education today. Today's a really important day for us. It's the first day that we formally address the idea of how to actually solve an equation. So it's like welcome to the rest of your math life kind of day. I'm going to be pretty particular and bossy today about the way I want you to do this. I'm not going to today is the day where we pretty much learn just algebra 101, how to solve an equation. And I'm going to be pretty bossy for about the first few weeks. After this, like come mid-September-ish, I'm going to totally pull back the reins and let you start showing less work. There's going to come a point where I'm like, you don't have to show me what you did. Like if you added 5 to both sides, that's okay. But for the first few weeks, it's not really going to be like a negotiation. It's going to be, I want you to show your work like this. So I'm going to model for you today as we go through our examples exactly how I want you to solve equations. Every little detail. The only difference between your notes and what I put up here today ought to be that maybe you're not using colors like I am. But every little cross, every little line, let's form superbly good habits on this first day. So today is the 26th of the 8th month, and we are going to be solving one-step equations. Everything we do today is one step. And equations in this class will eventually get to like 5-step equations. We might even get to 6. I don't know if that's realistic or not. But today's a warm-up day, and the assignment today is pretty much a warm-up-y kind of assignment. But again, we're going to form good habits. So what we're doing is we're solving equations that can be killed off in one step, and we're going to do 12 examples, and I'll try not to make this take too long because you probably want to get your work done. So here we go. This will be number 1 of 12. So here we have an equation. What is our overarching mission when it comes to solving equations? What are we trying to do? Find the number that makes it true. Find the variable. Some people say get the variable by itself. That's another good way to say that. So if I think about my mission, there's a number on the board that has to die. Who is it? 6. That -6. And how do you make a -6 go away? Good. And so I want you guys just to take a look. We're going to be really particular. Again, if you just say today, I'm going to train my habits in today, it's a lot harder to train them in next week if you're stubborn. So every little detail, we're going to add 6. And notice that we don't just do it on one side, we do it on both sides. That's the law of math, right? Now I'm going to do what I came here to do, and that is to make that -6 go bye-bye. So I'm going to cross it out like this. Now, before I worry about the math answer, because I'm not worried about it yet, you're going to hear me say this all throughout the hour, drop down the structure of the equation. At this point, I couldn't care less what the answer is. I'm just going to bring down the k, and I'm going to bring down the equal sign. And now we can do some math. What is 4 plus 6? It is 10. And if you want to know if that's the right answer, what could you do? You could always plug it back in, work it backwards. You could take the number 10 if you wanted to. I'm never going to make you do this, but if you wanted to, you could put 10 right where that yellow arrow is pointing and just see, does it work? Just -6 plus, it works. What I like to do once I'm sure I've given the best answer that I'm capable of, I like to put a box around it. It's a good habit to box up answers because it kind of tells people like, hey, this is my product. This is the answer I want to give to you. Box that sucker up. Next example. And don't worry about what the answer is. Let's use our time today to drive home that structure, that repetitive sort of habitual behavior. Do it the same every time. What do we do to both sides? We subtract away that 5, right, guys? So to +5, to kill a +5, you use a -5. Close it off with a line. Close it off with a line. And before we even worry about doing math, there's some housework, some house cleaning to do or housekeeping. What do we do? Let's cross that stuff out. Do what you came to do. And before still yet we worry about what the math is, what do we do? Bring down all that structure, right? So heck with -3 minus 5. He can wait. I'm going to bring down the m, and I'm going to bring down the equals. And now we can do the little kitty math. What's -3 minus 5? -8. If you feel good about it, box it up. And that is it for section 1. There are 5 sections in our notes today. If you have any questions on section 1, add sometimes, subtract sometimes, show your work. And I promise you there will come a day once you've proven to me that you understand like the theory behind this, we're not always going to be showing this much work. Right, on to the next section of problems. And the next section of problems deals with division and multiplication played together. Like this. What's our mission?
I'm trying to get the M by itself.
Yes, get that 3 out of there. Get the M by itself, however you want to say it. However that comes out of your mouth, you know your job is to kill the 3, right? How are you going to kill him? You're going to divide. Because your job is to identify, it's not just a 3, it's a times 3. And to kill a times, you use a divide. In algebra and every other math class you ever take, it is assumed that you will use this for division. You do not go off to the side and put the little 4th grade division sign. Division and fractions are now in our world the same thing. So we're going to divide like this. And again, you're going to do what you came to do, and that is you're going to X out those 3s. Next. Bring down the structure. You got it. Structure, man. Rebuild that house. When we get to like 5 or 6 step equations, every time we do a step, we rebuild the structure. Rebuild the structure. And you just keep doing it. That equal sign doesn't have to be perfectly vertical, but you ought to see the flow of that equal sign just tracing downwards. You get the equation to be shorter and shorter and shorter. M equals, math problem. What's -24 divided by +3? -8. And if you feel good about it, box it up, and we're on to the next one. And the next one is -36 equals -4. Why? I can tell you from years and years of experience that oftentimes, if a kid misses this problem, it's because they added 4. It happens a lot. So we just have to say that's not a -4, that's a -4. And what is it doing to the y? And how do we kill? Right. Your job is to always say, how can I pry you off of that variable? There's a job. There's always a job to do. -4, divide. -4, divide. Do what you came to do. Cross out those -4s. Drop the structure. I know I'm doing my job right when I can get you to just drop that structure. When kids are just looking at it and already knocking out answers, it's like you're kind of missing the point. We want to form these habits today. What's a -36 divided by a -4? +9. Feel good about it. Box it up, and we're on to the next section. Any questions about those? Section 3 at first is going to look a lot like section 2. However, you're quickly going to realize why. I think you're going to realize why it gets its own section. Problems like this. This part of the lesson isn't so much about what do I do first. This is about, oh no, what do I do now? Something uncomfortable happens. Let's talk first about the what to do's. What are we going to do to both sides?
You're gonna divide by 8.
We're going to divide by 8. And this is where the sort of Houston, we have a problem sort of thing comes into play, because I don't think you have to be a math whiz to know that 12 cannot be divided by 8.
Okay.
So since you're now going to hang out with people just like me for the next few years, teaching you high school math, maybe in college, I can tell you that most, if not all of us, do not want you to put 1.5. We don't want you to type it in a calculator. We want you just to say this, like, okay, I accept that 12 cannot divide by 8. Therefore, my answer will be a fraction. Not a decimal, not a mixed number, a fraction. And if the top's bigger than the bottom, that's okay. I wish they'd quit calling them improper. It makes it seem like it's wrong. They should call them like awesome top heavy fractions or something, because they're not improper. However, I would be upset. Not upset. That's not the right word. I would use my red pen and take a point off if you left your answer like this. Why? Because it's not simplified. And remember, simplifying doesn't mean to turn it into a decimal or to turn it into one and some fraction. It means simply to reduce the fraction as much as you can. What can 12 and 8 both be divided by? Therefore, the acceptable answer to this problem is m equals 3/2. Not converted to any other form, but for God's sake, simplified. That's what this section of the notes is dedicated to, is just accept the fact that sometimes numbers don't divide, leave it as a fraction, move on your way. Let's look at another one.
Is it this?
Yep. ¿Qué tenemos que hacer con este problema?
I don't know what you said, but that was beautiful.
Tenemos que añadir, restar, multiplicar o dividir. Dividir. Perfecto, right? We have to divide both sides by -3 because, again, we recognize that that -3 is not a -3. He's a timeser. And to kill a timeser, we use a divider. So we're going to divide both sides of this problem. Vamos a dividir los dos lados por -3. ¿Sí?
See, you cross the threes.
Going to kill those because that's what we came to do. And then we're going to drop the m, and then we're going to drop the equals. And now we're going to just assess the landscape. What's a positive divided by a negative? Well, let's get that out of the way first. And what is 14 divided by 3? It's 14/3. I asked that question earlier and people wanted to say things like, okay, it's a 4 and 2. No, you're missing the point. Leave it as a fraction. And 14 and 3 can't be reduced, so we just call it good. You feel good about it, box it up, on to the next one. I have one more in this section. In the notes to this point, our little sections have kind of had 2 problems each. This one deserves 3 because of this.
Because it's special.
It is special. What do we do?
Okay, we divide 4.
We separate, we divide, right? So to get rid of the 4, we divide on both sides by 4 like this. Oop.
You cross enough.
Let's cross those suckers out. Kabam. Bring down the structure. Heck with the math. Bring down the structure.
Special.
K equals. What's a negative divided by a positive? Let's
Negative.
get that out of the way first. And what in God's green earth is 1 divided by 4? It is 1/4.
1/4.
Again and again and again, we need you to be comfortable with the fact that sometimes numbers just weren't meant to divide by each other. You can't say 1 divided by 4 is 1. It's not true. You can't say it's 4. It's just not true. 1 divided by 4 is 1/4. You feel good about it, box it up. The last 2 sections of our notes today deal in killing division. So here is, this should be like your 8th example. This is the 4th section. So
Okay.
and again, just so we're clear, like I don't even think for a second that there's a single person in this room that doesn't already know what the answer is. I mean, I'm asking you on the board, what number when divided by 3 equals -2? And you're like, well, that's -6. That's not what today is about. So to get rid of that 3, what are we going to do? We're going to multiply. And in upper level mathematics, like in grade school, you could put cute little x3s and stuff. Now, when we multiply, we put parentheses. You put some big old jumbo monster parentheses around that whole equation. Everybody loves parentheses. They're so easy to see and understand. And what are we going to multiply by?
3.
The 3, because that's what we're trying to eliminate. So we put a 3 and a 3, and we do what we came to do. And that is murder off those 3s. Then
X equals. And then you times -2 by 6.
done. And if you
Which is
feel good,
-6.
remember the box should only happen once you feel good about your answer. Box it up. Let's do one more of those just so, because I don't think one sometimes is enough. And then we'll get to the harder ones and then we're done.
And
¿Qué tenemos que hacer con este problema? Said, what do we have to do with this problem?
same thing, but different. It's
Tenemos que
numbers.
multiplicar por -7. Perfecto. We need those big jumbo parentheses because we're gonna multiply both sides by,
-7.
you betcha.
And then what we gotta do is gotta model the sevens off. Bring down the structure.
Bring down the structure. And as will be the case all day, every day, the question is, can you actually do arithmetic? What is -7 times +6? -42. You feel good? Box it. Are you ready for the last section?
Hold on.
These will be the ones that are harder than the others.
Mm,
Not difficult, just the most difficult.
There you go. And then the last section is section.
So the last section is involving fractions. So
I feel more comfortable with fractions now. Maybe.
I think the reason sometimes that these are difficult for people is because, and I can already tell, despite the little hiccup at the beginning, that we're going to be a really good group. You're listening well. I can just tell you're picking this up. You're good, good, good. The trouble is at this point in the lesson, if you've walked right down the pathway with me here today, I would ask you questions like this. I would say, okay, you see the variable, right? What number are you trying to get rid of? -2/3. And how do you get rid of that -2/3? Because he's attached to the x by times. How do you get rid of him?
You gotta divide it. Man.
And that is not the right answer. So what we're going to do is we're going to multiply. And if you've never done this trick before, if you think about it, dividing by fractions kind of sucks, right?
Yeah.
Because at the end of the day, you go, well, wait, if I divide by a fraction, don't I just have to flip it over? And you remember that? So let's just copy dot flop right now. Let's cut out the middleman. And to get rid of that fraction, don't divide, multiply by the upside downy guy. You guys remember what upside downy dude is called? It's called the reciprocal. Yeah. So to solve problems like this, you actually flip and multiply. Your brain will tell you to divide. Say, no brain, I'm not going to divide, I'm going to multiply. Quickest way from point A to point B. Now I'm going to do what I came to do. I'm going to kill off these numbers on the left. I'm going to drop my structure. And now I have a math problem. Stay with me. I got about 5 more minutes, 4 more minutes. And we're at the point where your brain's starting to shut off. Stay with me. You will remember last week I taught you this little thing called a fish hook, right?
Yeah.
The trouble is this time the fish hook doesn't work. Sorry. Why? It's not because they're backwards. Owen, Ollie? It's because 9 isn't divisible by 2. Perfect. The fish hook is awesome when it works. And when it doesn't, we have plan B. But the 9 is not divisible by the 2. Therefore, fish hook is not the approach to take. The approach to take is what I'm going to write in green. And that is to put the 9 over 1 and multiply like this. Got it?
Time.
Do you see anyone in the green math problem from the top floor of the hotel that can reduce with anyone on the bottom floor of the hotel? I don't. 9 can't reduce with 2. 3 can't reduce with 2. In a case like this, we're just like, suck it up, buttercup. You get what you get. What's a positive times a negative? So my answer is a negative. What is 9 times 3? What is 1 times 2? Your answer then is -27 over 2. Done.
Oh, bam. Thank you.
And you can't simplify it. Here's a life hack for you. Are you ready? You see the green math problem up in the corner?
Mhm.
Take this, kids. If you can't reduce the green one, you'll never be able to reduce the white one. Some people hear me say that and they're like, I don't even know what you said. Some people go, really? That's huge. If you reduce everything when it's out in the open, you'll never have to reduce it later. Pro tip. Let's go again.
This helps. Thank you very much.
You're very welcome.
Um,
What do we do here?
the same.
Hey. Multiply. I never want to willfully head in and say, I'm going to go divide by a fraction. No, ain't nobody got time for that. We're going to flip it and multiply. What's the flippy dooski of the fraction I'm trying to kill?
5, 6.
Negative.
-5, 6.
Good job. So that's what we're going to multiply by on both sides, just like this. And I'm going to do what I came to do. I'm going to cross out these -6/5 and -5/6. I'm going to bring down the structure.
Yeah.
And I'm going to ask you again, now that you know the answer, will the fish hook work?
No,
And all he doesn't get to answer it this time. Why does the fish hook not work?
because 9 is not.
Nine's not divisible by 6. Bingo. If I try the fish hook, if I try to go la 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 and fish hook it out, I'm going to hit a wall right away because 9 isn't divided by 6. So fish hook, we bail and we try plan B. And plan B, remember, is just good old school. Stick that 9/1 and let it go. Do you see anyone from top floor of Hotel Greenie that can reduce with bottom floor? Either you're throwing gang signs or you're telling me to do something with a 3. Is that right? Good. I see a 9 and a 6 that can both be divided by 3. And I'm saying again, if you reduce it now, you won't have to reduce it later. If I divide both of the red numbers by 3, I get 3 and 2. Do you see any more reducing? Me either. So it's time to commit to the final answer. What is a negative times a positive? It is a negative. And what is 5 times 3? And what is 2 times 1? And that is your answer. And there's one math problem left for the notes. Solamente uno.
Yeah, and you box it up.
Y después de eso podemos hacer la tarea para esta noche. Así que no tienen que hacerlo en su casa. ¿Sí?
Casa means house.
No, but I did see your mom at Sam's Club yesterday. Were you with her?
Associate with people outside of school.
Were you with your mom?
Yeah,
I didn't see you.
and my dad was there too.
Oh, I see how it's going to be.
You don't understand.
Friends off.
Okay, so what you do?
So,
you put the
Same
whole-
thinking. 10 minutes ago, you might have said, let's divide. We know better. There's a fraction. How do we kill a fraction like this?
Times.
We multiply. It's so
multiply.
counterintuitive. To multiply to killing multiplication is like so weird, but we're going to do it. What is the flippy dooski?
4/1.
-4/1. And the last I checked, it's a lot more efficient to write -4/1 as just -4.
Oh, oops.
What is it they say? Keep it simple, stupid, right? So if you can make something easier, make it easier, and don't put things over 1. Unless you have to. Okay, if you really like it, you go, you get down with your bad self. Now, what I'm going to do is I'm going to cross out these numbers over here like this, ka-choom, ka-choom, gone. And I'm going to bring down these,
That's all.
and we're again relying on our little kitty math. What's a negative times a negative?
Positive.
6 times 4. And if you feel good, what do?
Box it up.
Full cent. The box is the full cent.
Boom.
It is at this point that I will terminate the recording, and this recording will probably be up on YouTube, either yours or Third Hours, here within the next hour for the people that are not here. In the meantime, you're done. So now what you do is you get out your paper and your pencil and you open your Chromebook and you go to Delta Math, and you will now see over on the left-hand side A1-1. That stands for Algebra 1, assignment number 1, and it'll say solving one-step equations, and I will get you something to do on paper for today.
So you use the-